Then it says, okay, it's bringing it to so it's like a student about this or locating. So then it's right here. So here you get the last one. So then here it's and this you still have access to our variables. So you can still know A and 1.
Okay. Oops, I forgot. So if here I already start the Zoom, and then if you want to check, I have some answers already on the first part, so you may be able to find it about C purpose. Okay, if you want to check the solution, go back to the video and then you can check. Or if I maybe I'll post it after the just kidding. Okay. You can check the solution, just say some screenshot. As what you know, because I know some of you have really have a problem working on the assignment, and then I received the email. So you should able to see the deadline I already extend to Friday, 23:59. So you can have extra time to work on it. And if you already submitted, you feel free to modify and change it. So I will just like wait after Friday night. Okay. So I just like maybe some of you like asking want to go through the assignment again one more time. So let me I have one. No, this one is too small. Okay. Okay. So I know maybe some of you not really familiar with the C purpose. Just using C purpose because it's just like common when we teach operating system, because C purpose we use it to like better to access the memory. It's like have a low level language, so we can like access to the memory directly. Okay, when we're using the advanced level, let's say I use the Python or I ask you to using Node.js. Yes, if you are able, like based on my sample code I provide to you, and then you are able to rewrite everything, make things easier, you're welcome to do that. And then once you submit, but just like if you execute and show out the print the result, just remember to show me the result and also upload your source code. Okay. So if you are able to like change it, so just choose the language you think you're good at. Okay. But everything we are doing, or even the assignment I give you, just simulating how the operating system is doing. So let's say I tell you for the first assignment, I tell you we need to simulate how the fetch and execute cycle it works. Okay, so right now this one I already compile and run it. Let's say you already I give you some instructions. So if you see, so we have an instruction like low A10, low B20, add B, and then store to a location and hot. Just that means terminate, stop it. Okay. So when we receive all this instruction, how the OS system is working. Okay. So I try to print out all the instructions so right here. So actually when you just like print the like the C out, or like you can just any log to print it out. Okay. So from the sample code I gave you, you can modify, change it. Actually you don't have to really just say use everything I gave you. If you're feeling okay, I can use maybe some vector, some array to read it. For the idea, like let's say if I get an instruction low A10, maybe you are like kind of stuck. Actually, from the source code I gave you, you're already able to break it down. So the idea is like, okay, when I break down this part low, so I have an opcode. So how can I match this opcode? So for the opcode serial run, so from the right here I gave you. So here's the opcode right here. I already bigger. Okay. Let me change the font size. Font size 24. It's too big, I cannot see it.
So if someone told that you can say that the memory range is
Mhm.
it's good, so I was thinking we have to get the opcode, like encode that into the array and also have like A goes into the array and then whatever value is also. I thought that was all part of.
Okay, so actually, from the source code I gave you, so actually the source code I gave you, actually, when you read it, opcode and arguments, so we break down to two parts. So the right here, opcode would be the first part. Because when you, if you know the structure right here, so we will read until the first space, right? Okay, if you know C++, like right here. So when we read the first one until space, we will read the opcode. And then the first one, the argument push back. Actually, that one is the array. So the array argument 0 will be first parameter. Okay, the first one. So if I load it, if I get the low, so opcode is low, right? And then arguments 0 will be 8. 1 is 10. Okay, so just like follow this logic. Okay, so here's I already gave you, like we have a like encoding instruction. So once we get the from the low, then we change to I return this one. Okay, so this one is a hex. So I just give an example. You can check it. It's an opcode. So what do we need to do? Just like mainly is in this part execution. When I give you the example right here, remember just like throw the error in case like something it doesn't match. So this one is as an example of loading. So if I get the opcode low, then what should I do? Yeah, then something. Yes, thank you. Okay, so when it's low, what should we do? Okay, so the arguments, well, right here is the arguments, right? So I pass it right here. So arguments I pass here. Okay. So argument 0 is A. Okay. So we have right now I gave you, if you remember, I gave you, we have how many registers? 2. So what the register name are A and B. So that means that it's possible. Can I load from B? Yes, it's possible. Also, I can load from A. Yes. So should I check which register are we using? Yes, then what should we do? Is one? So how can we get the value of the array? Do you know how to get the? Yes. Okay. So first one. So first one is the register. So, but right now, how can we know what's the value? Then we need to check, right? So are we going to put the value into register A or register B? It's a really huge hint, right? Yes, yes, okay, yeah. So use if to check, okay, which register should you put? And then just save the value to that one. Okay, then actually, if you finish this part, you're done. Okay, so you already finished. So just like you need to determine what's the value like in argument 0, because 0 it will be the register. Okay, and then 1 is the value itself. Okay, so basically the structure for loading is okay. Then how about B? App B. Yep. So so we add the, so that means, do we still need to determine like which is the, like which one add to which one, save to which one? Okay, I just confused out. And if I say right now we load A equals to 10. So after we execute 2 instruction, so right now A actually it's just variable A, right? We say it's register. We're just using C purpose to simulate it. Okay, so variable A, that means representing register A is the saving store 10, and then register B store 20. Okay. So when we say add B, that means what we're going to do right here. Okay, yeah, so add B to A. Okay, so add it and A becomes 30.
I guess. So we're only using 2 registers here, but obviously. Real CPU would have more.
Yeah, of course, yeah, for the view register, we have more than that.
Say we're continuing to add G, would it automatically know to add it to A?
So this one about the we call the assembly language, you know. So when we load the value and add, so anybody can help to explain. Okay, so if can I say load and then add?
So I think that the fusion is, and then two, we're saying add B, but we're not specifying what we're adding to. So normally in assembly language, you would say add B and the value stored at it.
Okay, so actually they're working together.
So we're just automatically assuming that anything we're gonna add, we're always gonna add it to A.
Yeah, the first one. Yeah, okay, yes.
So
Okay.
that's just an assumption.
Yes, yeah. So it's how the assembly language is working, like not assembly, it's machine language. Yeah, because machine language or assembly language is we're using. Okay. But we're not really covering, but do we take any class about the assembly language? Okay, a long time. Okay, man, you already forgot it. Okay, so here's the idea. Because when we working with the here's the things, because if you the OS, we work on the working on the application layer. Then the kernel, like I talked about last time, like kernel, what's kernel doing? Kernel is helping you to deal with the things like this. So when we say like variable A plus B, like or like equals A equals A plus B. Right here. Say message. How to define the low A and low B and decoding. Oh, sorry, I blocked myself. Differences. Okay, there's a question. If you can see it, then I will wait. We can discuss about this one. If how do I think? Okay, so if we are writing a program like this, okay, we're too small. Okay, like we will decay. So when we put in like A equals to A plus B, right? Or like sometimes because we already save a register, because AB is the register, so suppose we shouldn't use AB. So I say var A equals to 10, var B equals to 20, and then we can say var equals var. So it's much more make sense. Right now, okay. So right now I will declare a variable called variable A, but we don't know actually which register are we using. So this one, the OS help us to handle it. So like depends on the memory. Okay, you do it. But we will just like say that 10 over there. So we just load into it, like A load get the value 10, store the value 10, and then value B, just variable B, save 20. Okay, so I say if we are only registers, so A store 10, and then variable B will store like register B 20. Okay, so when I say edit this one, so I just like add B, right? So the instruction is add B. So anything will save like back to A, like this. Okay. Yeah. So, yes, by default. Yes, it's a like assembly language. The machine is like that. So when you put the line like this, the kernel like actually will break down to like so many instructions. That's how it works. Okay, and that's why we just like simulating how it actually the OS system, the kernel help us to handle it. Okay, and is the what's the question comes out? Okay, so they say when I encode the instruction, how to differentiate the low A and low B when decoding? I think I already answered this one, right? You already answered that one. Yeah. Okay, so low to the middle. Actually, when you execute okay, so we are simulating it. Okay, we are not actually, because when the mhm. Mhm. Loading to CPU.
I'm not sure I'm not the same issue because the part that I was stuck on for so long was just
Mhm.
not really getting strings from the program vector
Mhm.
into the memory, the unsigned memory.
Okay, inside memory.
So
Okay.
I understand. So like the instruction is load A.
Okay.
So do encode instructions turn the load into character, put that into the array. Do A and 10 also need to be in the memory?
Okay, got you. Okay. Okay, got you.
With your, because up there it says memory is just
Okay.
1, 1, 2. I understand those are like the load, add, but then where do the A and 10?
Okay, because that one because we are in the register, so you don't have to. Yeah, just like yeah, true. Yeah. So because we low it, so for the memory, just like nothing. Yeah, so you don't have to worry about that one.
So then how that,
Mhm.
where
I think in those
so then when you call decode,
Mhm.
you're putting in the instruction and then you can understand the I string. So then where are you getting the instruction string from to be able to get both the opcode and then like A and
Actually, I already gave you. You say where can actually I think when I gave you the source code, this one get a CPU. So actually I already provide everything to you. So you will actually call the low program. So this program already passed to low program, right? So low program right here. So I get the program here, and then actually I show you like just call this function. Maybe you need to pass some parameter. So I think you should able to get okay. So when we call the encode instruction, then what we're going to do is okay. So execute something on the encode instruction, and later we need to fetch the like after we call it. Also, we have like fetch it, decode it. So actually, decode is like we break the line by line to like one opcode. So when we do the decode, we will execute like should. Yeah, determine. Yes. So right here, like we'll determine and then put everything in this stage, like in the execution stage. So we will store the value, the argument, everything to here, but we don't have the yeah.
Can you show the,
Which one?
it was on the right side.
Riser. This one, okay.
So at the very beginning,
Mm-hmm.
he loads his program. He actually doesn't need any of these arguments. He's gonna come back to those. So he's only getting the opcode and then putting the opcodes in the data. Because when he comes back to those arguments later, he'll already know what he needs to do. He just needs to- Right. but where the arguments-
So.
Yeah, the
okay, so
arguments
where do the
already
arguments
stored.
come?
Does decode past the strings from the program vector directly? Are you calling decode with the vector? No, not decode instruction, but decode, the one where it has the I string.
Okay.
Where it's the const instruction. It's, so you're passing the string to decode. We have.
Decode it will be complete. So right here when we're waiting, so when we execute the decode, so you will see the instruction, right? So one instruction is just like one single line. Okay. Okay, so you can follow this part, right?
So
Okay.
the whole line is the embedded C code, not just in that the decode from the fetch. Like the fetch the instructions. So where do we get that? And then the fetch goes to the memory. But the memory only contains with the upfront.
So right here, if because when you're asking, so right here we have function called decode instruction. So I say you can call it, and then we should do something right here, like so based on the encode, like when we pass, like
So then, because then your encode, that's when we pass from the memory area, and that's going to output the string that says, okay, load, add, all that. But the part that I think a lot of us are stuck on is where the arguments come from. They get passed into, or where does the full string come from that goes into decode to then also get the arguments? Is that straight from the vector, the program vector?
actually will be okay,
Not that, yeah, not decode instruction, but decode.
decode this one.
So like you're calling decode,
Mhm.
and the parameter is the full string instruction.
Mhm.
Is that coming directly from the program?
From the program vector, actually is from the encode right here, right? So encode, and then we call the decode. So we just pass one single line. Only getting the
So
opcode.
it's okay.
Okay.
Can I?
Okay.
What about, can you show us
Mhm.
the switch statement, what maybe the load would look like? So for example, if the case was 0x01, can you show us what that block would look like inside the decode?
Okay. Let me. Okay. Let me show you the. Okay. Yeah. Actually, as a first assignment, I will let you see. Okay.
Because then you can just return the string.
Okay.
If you're
Quickly. I'm not really sharing. Okay. So okay. So actually sometimes this one slightly maybe confuse you. So encode instruction and then the decode instruction, like I just like, because sometimes when we get the low and then also like for the encode and decode, just like converting. So that's why actually you will see the part of it right here. So the reason why I keep part of it is just to help you to like doing reverse, okay, to match it and then return like the low. So this one is called the decoding. So try not to confuse you, okay? Okay.
So that'll give you the opcode for the decode.
Decode, yes, okay.
So
Opcode.
where the arguments.
Okay, so for the arguments right here, okay, let me close it. Okay. So when we load the program, so when we try to call it the decode, we will try to call the encode function pass this instruction to it. Okay. Okay. So we use this one and then I will save it in the memory. So the instruction will be like for each single line. I will call the encode instruction, right? So let me go to encode instruction. So I will see, is it became like, does it begin with it? Okay, got it. Okay, so
And that will return
back.
just the
Okay. The opcode, yes, correct. Okay, so you get the opcode. So okay, so for this one, it's like we are done with this part, and then when we loading, so it's like for each one, just like opcode, like which one 001, like, so you know the opcodes right in the memory. Okay, got you. Okay, just that one, save it, and then just like keep going. You already have a fetch cycle, and then for decoding, so we will pass the instruction, right? The decode. So you need to find like where should you put the like chase it back, like where should we put the decode function? So the decode function just like have a assignment. So just like let you see. Okay, I cannot really tell you, just like cover, like let you have some challenge. Okay, so we have the decode, then you need to think where should I put the decode, and then when we get the decode, and then we will try to break down each part of the instruction and then see, okay, where should what should we do? So after we decode it, then we should call the execute. Okay, so that's how the execute with the switching function. Okay, so we are based on this one, and then okay, got you, got.
I think I see.
Okay, so we have the load function, add function, subtract function, all these functions. Okay, this one is the simplified version. I have a more like the one I'm showing to you with all the logs is even more complicated. Okay, so you can make it more like, but this one also is the same. So I just like break down of load function. So Bill, I know you've like lost the idea, so I let you to see it. So okay, so when you a little bit right here. Okay, so actually I'll be recording. Okay, so actually even we can just as a use case that help you to really understood. Okay, so right here when we are in the execution cycle, so I need to check the opcode, right? For the opcode, and then I will determine, okay, based on opcode, I will call the function. So this one is more likely is for the implementing a function, like you know the methods for program. So for this one, I will check, okay, just like for this one for security. So I make sure the instruction, okay, if for load function, I need to make sure I have two arguments. I need to know the register and the value should I put in it. If I don't have it, that means that maybe there's certain error or the translation, you know, some issue. Like if we have a low instruction, but we didn't have enough argument, that means it's not an appropriate one. Okay. And as what you're saying, we're using the if condition to check, okay, which register we should use, and then just save the data. Okay. That's it. So that's how we use the load function. After we finish, I just like log the information. That's an execution cycle. So you see right here. So when I'm running, so based on each instruction, like I call the fetch, right? Save it. So if you see the fetch, let me see the fetch right here, the original. So when I just like keep fetching it, what should I do? And when I fetch it right here, so I get the instruction, just decode it. Okay. So here's the idea. So mainly we just like execute the run CPU.1, you see. So everything is like mainly calling from this part. Actual right here. Okay. Okay, I try not to block it.
So he has two decode functions. One's a decode instruction, and one's decode. So whenever he calls decode, it puts in the whole line, and then it sends for you.
Okay.
It's already loaded it into the instruction variable.
I tried here.
Instruction is just the line we're on.
Yeah, but that's an element of
All we have
of
is
the stream.
Because all we're taking is from memory, all we have is the object. So where is the argument?
Are we taking it from memory? We're loading the program from the quotes below, are we not?
Right, but we're gonna put it into memory.
Yes, that's correct.
So then why would you not take it from memory?
Why would you take it from memory to put it right back to memory? You see what I'm asking? We're getting the things off the bottom and we're putting them into memory.
Okay.
Then we're gonna execute.
Right, but you're gonna take what you put into it, you're gonna execute what you put into memory. So
Um,
there are arguments.
Yeah, I actually what you argue actually correct. Like you talk about memory we are getting, but because we better just simulating. So I don't want to like make it so complicated. If you really need to, we need to save like we need to know the address, the memory location to get the value and then load it to the register, right? But this one I just say you just like get the from the instruction and then save to the register. Okay, so we just skip some part of the steps. Okay, bypass, yes, we do. Mhm.
So normally, whenever you write code, you save that code to memory. And then whenever you want to load it, you would load the code from memory and then put the pieces you're working with now into.
Okay,
If that makes sense.
Okay, so we're just,
We're just kind of skipping that step.
yes,
We're pretending like we are.
yes.
So whenever we call that line, we're technically getting it from memory.
Okay, yeah, if we need to, okay, if I remember, it's the,
I didn't really
with
understand
for
why
right here. Like when we have a really actual process, like let's say we have process, but not because when we assimilate right now, just actually just one single statement, just that one is like just like a plus b, a equals a plus b, and that's it. Okay. So of course, like you say, why we simulate, just let you know, okay, we have opcode load to the part of memory, saving opcode, and also we have the data memory, like saying loading to it, but we just like skip that part, so we just ignore it, okay? So for the memory, you see is the opcode like 01, 02, so you know like which is okay.
So, but then,
Mm-hmm.
yes.
Mm-hmm.
Yes.
Mm-hmm.
In actual processing, though, like the whole instruction is loaded into like so like
Yes,
the
I
A
think-
and 10 are gonna be in one spot together. So
A and okay, A. Okay, so
and it's that instruction, that whole thing is the instruction.
if you know for opcode, like first like opcode, also A is the register we are going to use. Okay. Also the value itself is stored in the main memory. We have the address. Okay. So actually we have three things like opcode itself and the register address, like which one like we are using, and then also the yes, yeah, yes.
In reality, it's all program. Because it's simplified. And it's losing all that. And
Yeah, so that's why yeah, just like similarly, but I showing the sample code or like the solution because some of them we just like bypass it, we cannot like simulate everything. Okay, so just knowing when you get the opcode and you are able to look it, and mainly you see the output right here. So you see compare refer to okay. Actually, if you go back to the video, you're able to see the answer. Okay, so here the opcode. So if for low, and then we have a add, and then we will stop it. So 6. So in the memory, so you see like all the memory always right here. So just check the opcode. Okay.
I guess,
Mhm.
going back to what they were saying,
Mm-hmm.
so you don't want arguments in
we are not putting the arguments in the memory. For this memory, just saying the save the just opcode itself. Yeah, yeah. Because in actual operation, it's true. Like because okay.
So I guess
Uh-huh.
with just the opposite, what does a jump? I guess,
Okay.
I guess
So
a jump would
this
just change.
so in this memory is more likely is
Where I'm getting.
okay, because you asked John, right? So just like how we call it, because if you ask this one, we need to go back to. So what's John using? Yeah, so sometimes if you remember the assembly language, sometimes if we have the loop or somehow like, or like if we need to like some statements, like if something happened, then we need to like, okay, why now I'm not executing this one? So I need to jump to another instruction, right? So I just use jump. Okay. So just like this one, that's why we just simulating. Okay, we maybe have different type of opcode, and then we change it to actually when we store it, just like this. Actually, this how we store it. But in the kernel level, we see is the assembly language, and then when we change to like really the hardware, like in the digital, actually it's like this one. Storing in the format is like this. So like in behind, like that's why we have called that encoding instruction. That's like in the kernel level. That's what it's doing. Okay. And for the memory, don't be confused. Just thinking for the opcode, that means we have the list like showing, okay, first instruction, like for the instruction, what should I do? Second instruction, what should I do? So I put all this like in the memory, like save it. Okay. But we have main memory to save the value. So don't confuse with this one with this memory. Okay. Okay. Okay.
So in our example,
Mm-hmm.
I would use jump to, so let's say you wanted to jump to, you change the PC. Yeah, you just change the PC value.
Yeah.
So
Okay.
if you're jumping to a specific place in memory, what happens if you jump somewhere like we've got 256 unsigned characters, so I don't expect jump to 128.
Okay. Okay.
Negative.
First, because like for this question, when you're asking, I don't want to. Okay. If you ask this one, then maybe you still, if I understand what you're asking correctly, if you're asking this one, you jump. This one is keeping the opcode. Okay. So if I'm more than that, I'm not able to execute more like the instruction. Okay. So this one is more memory. But when you say when I jump to some certain memory, like something like that, like you say maybe a program counter, like if I jump to that one, then out of it, of course, we will throw or like handle it. Like if we are like jump off it, then we need to like, let's say it's a, because for OS system, if I say I want to jump out of this range of the memory, are you going to let me to do that, or like let this instruction going to happen? Yeah, so that's why we need to catch it and throw it like error dot say it's possible. Is it possible? Yes, when we implement like maybe the memory address, like of course, like override register value sometimes mix up, especially in the assembly level, maybe we misuse the register something. I just assign register, like replace the program counter value, then you just jump over the range of it. Okay. So it do happen. So just catch it. Okay. So when you're asking what is going on. Mm-hmm.
Throwing
Mm-hmm. Okay, actually, it's pretty similar. I think in the assignment I give you say following the instruction. So let me show you right here. Okay. So if you want to throw, let me get the throw instruction. So like you can if and then throw range error right here. Right here. So you can see. Okay. Okay. Okay, let's say you can fold it. So okay, so out of the bounds. So if you have something like this, if you using jump, okay. But of course, in this example, we didn't have a jump opcode. Okay, so but if you want to try, you can add more opcode and then try to do it modified. Of course, you can test it. But for this one, just like simulating, if you can finish all those functions, you're good. Okay, okay. And after when you look at it, I think you have like clear about what's doing for this program. I just like try to divide everything really detail, but of course, if you think it's too complicated, you feel free to. I can show you one more. Like, let's say if you want to change it, I have one more like for the JS file. Okay, so it's pretty similar because you are working using the C purpose. So I just show you another version. I help you have a better idea of it. Okay. So right here, we are still same like loading program. And then just like also like decode and encode, we will the same. So the logic right here. So when we write the program, like every time we will fetch it. So actually we call the fetch is like we return the instruction. So call that decode instruction. And right here, decode. And in the top still is the same. But it's really hard to pick. Couldn't read it. Okay. Let me. Okay. Okay. If you can see it, okay. Okay. So right here, the main. So every time I will still call the fetch function. So fetch function is right here. So I will check, like make sure the program counter is like less than 256, like the memory range. That's what we declare. And then every time we should pass one, right? Then that's how we can know, okay, this time the output, what should we do? Okay. And then we will measure that based on the work, the opcode, and then we will load the argument. That's what we get. And then what we execute. And basically in this part is kind of like similar with it. Okay. The same checking which assignment, the value. And we just handle all these function. So after we finish the decode, like every time decode. And instead the decode, we call the execute. Okay. And then so after we finish, we just like print out the message and that's it. Okay. Then we finish everything for this code. So suppose that when you see the printing, let me see the so it's pretty similar. So over here is the opcode, same like opcode 11246. Yeah. We just assuming because like when the value is from the main memory. So but for this memory is like just it's kind of like a queue to save all the instruction we're going to do. Okay. I wish you can have a better idea. Is it good? Okay, got it. Okay, perfect. And okay, so I think I also post this part of the code in the assignment, so you were able to see assignment. If you want to refer to, if you, in case say, if you don't know how to, like catch and throw, so you can refer to this one and refer it. So here's one of the example for the low function. Okay, low opcode. Okay. And we have more. Okay. Actually, as a follow-up, and then if you still remember last time we not last time, but in the previous lab we talked about the when we have multiple programs, or like we say process to use or share resources, then how can we make sure that it's safe, or like we never go into deadlock, or like how can we make sure it's the safe mode? So there's like going to be a next assignment coming soon. Like I'll let you submit it, and I'll post the new assignment. So I just use the JS to simulate, but I later post it. So right here, I will let you see CD. Okay, and then what's the file name I'm using? I'm putting using Word 6.1. Okay. And the worker. Okay, that one looks better. So when we are running a process and then calling child, if you still remember, we have a system call. Okay, so we have a system call, and then we call a fork, and then so right here we would define. Let's say we have number of processes. We have 3. And then resources, right now we have like 0. So we can't, like that's how we set. And then maybe for the child, we will set the array, and then length with 3. And we will just calling it. Okay. Call the for function, and then every time but say n+1. Okay. That's it. And then when we call the child, and then we will just say add the value. Okay. Every time a share value, and then share the what's the count. Okay. For this one, when you see when I fork, I will try to include another file called worker. So this worker file, so it's how we actually do. Okay, let me the file. Right here. Okay. So right here. So every time like when I have a for function, so I have a child process, right? So if you remember the PID, that one this time. So when I calling it, so everyone I will call like a process, a worker right here. When you call the process, like I will just adding it every time and then send it back to add the value. Okay, so you will see the return value right here, update at 1, 2, 3, 4 until 15. So even I said 3, and then but because I execute 5 times, so will be 3 process execute 5 times. So total will be 15. Okay. And you should able to see this file, right? I already upload it. If you have the Node.js, because I know most of you have the Node.js installed in your test on your laptop, so we can try to download the first one, and then try to execute and see the result and print it out. Okay. And you need to modify because they want just like have like exercise one up because they won't help you to prepare for the your assignment too. Okay. How can you set the printing out? No, I will. This one is just like help you to see. Okay, so that's why I use another language. But you can let me know if you're feeling C++ is too difficult. I can let you to follow this sample code. So just let me know. Okay. So you say you want to stay on C++, right?
Yeah, that's just.
Yeah. So the reason why I'm using another language because I like just showing the logic. So you can like refer to it, but I'm not really directly give you the answer. Like how can you do that? Okay. So I will upload. I want to let you try the first one. It's the first one, the week one, and then the worker. So you need to download both of them, and then include it together. So you can put them together and then try to include. Okay. So that's what you can do and try to execute it, and then you should get the result like this one. Have a context updating the resources one by one. So if you're done now, you're ready. Okay, so can you get the result? Okay. So if you remember, I talked about like multi-process and multi-threading. Okay, so if you see last week 5, we have a lecture. Okay. Regular way, like for the single like for the one process, we have only like one single thread will be like this. But when we have multiple okay. So most of right now nowadays we have called a multiple process with like multiple thread, right? So with one, so we can as I like synchronize simultaneously executing like in the same like multiple cores. Okay, that's how it works. And then all of them they have their like TCP. So we have the PCB process control block, and then when we have the thread, then we have like for the TCP, the thread control block. So like this. So for this one is like simulating if we have a multiple, then you will see in the beginning. So if when you execute, so when we have an array right here, so we have the array is just going 3 times. So every time we will just like call fork, and then we'll pass 1 next time. Okay, just increase it. Okay. So here you will see when for the child I'm waiting for return message. Okay, so when I return it, and then if the type equals to update, then I will pass 1. So if later I ask you, maybe you need to minus it, do the multiplication by division, then you will know how to handle it, right? Okay. So the example right here, just adding it, okay, and then log the result. And then just like return. And actually when every time when I fork, then actually I will execute these pieces of program. So you see the message and return, so they match with together. So what's the message I'm going to return is right here. So if I give the message type is start, then what I'm going to do, so I will just like running a loop. So this loop will be let the update every time. So within this process, I will running a loop like 5 times and edit, just edit and send it back to the from right here. So I will update the resources. So every time after update, there are log. So you will see here the resources count. So it's like every time it's returned from the child. Okay. And here will be say, okay, so I just like saying initial right here. So for the child for each one, you can see the child right here for each. I will send the start. So if I send the start, then I will let the process know, okay, when I receive it, then I know I need to do update. This is the second kind of like second part of the function. Okay, so I initialize it, they're ready, we save it, it will update. So you will see structure right here. But this one we just declare the child. The child, we will set the loop, and then every time we set the start. This start. And then when we execute, we will just like running the child fork and then worker update, return, go back, update the value, and then log the resource +1. And next one, keep going, return, well, let it finish. And then next one. Okay, that's how it works. So if I want to see, updating. Okay, so I want to, if let's say I want to check the when I was that I am doing. Okay, so why now I change? So you see the P1, P2, and P3. Okay, so here's the next step. You can change like to print the message. Then you know the sequence better. Okay. And because I have like 2 more, but I will cover next time for the class. But I will show you the results for this one. With another second one. Okay. Open. Okay, so here will be more like advanced. So like if you have a safe mode, right? So how can we like make sure we have a safe mode? So we try to add a log. So this log like in the beginning, we make it as a false. So you can see like we will just based on the same one, we will always say adding the value. But if this one, the type is not yet is equals release, then we will let the log go to false. If no, then you is, let me show you this one. The worker. Okay. So we still have a local value go log, but if we set it, then we will make it as a true. Okay. So then that means that we log only this process can do that. So we just like guarantee, okay, when I access it, no other process like can I modify the value return it. So it belongs to like, let's say P1, then P1 can send an update. So every time just once. Okay. So this one is like, let's say I have a thread, right? Say we have thread, make sure only one thread saying can update the value and return it. Okay. Therefore, this one is possible is if we are using the first one, the first JS, maybe sometimes maybe the loading sequence is not the same. So maybe minor is still okay with just +1. But if we need to like modify based on the modified value and then to adding it, then it will cause the problem. So we need to add extra flag. Okay. And one more, just quickly, and then but for the details we will execute. And one more right here. So this one is like, okay, if I'm multiple, then I need to add a queue. So let's say I have a pool like 1, 2, 3, the resources, and then we have a queue, then we need to like, okay, if this resources is more than that, then I need to put it in the queue. I need to wait until it's enough. Then I will execute this one. Okay. So this one we just like preventing. So we just like avoid the deadlock. Okay. So because if we don't have enough resources and then we execute, then we cause that issue. Okay. So we just wait until we finish and release the resource. Then we will check again. Okay. Go back to the queue and see, okay, do we have enough resources to execute this thread or like the child process? Okay. So if able to, do it. If no, put back to queue. That's how it works. It never know. But you will tell, okay, hold on. If you say the process know how much, suppose it's like process when you declare, like we'll know how much resource they require to use. Okay, okay. So then how much, okay, let's say make it simplified. Variables. Let's say we have how many, if you declare 3 variables, right? Then we'll know we need 3, right? Maybe we need to have at least like available 3 memory address. Okay. So the OS need to check, okay, do we have something? If let's say I have running multiple processes in the same time, but for your application require 3, but I don't have maybe only 1 left, 2 left. Am I going to load yours? No, then I put it in the queue. I will wait under process like finish, and then I know, okay, it's available for this one, it's enough, then I will assign to you. So you say for process or the application itself, is I only telling you how many do I need. Okay. Get it? Okay. This is a question myself. You are so you are telling the OS how much memory or like how many resources do you require to execute. But as an OS, I was just like seeing, am I have enough resources provide to you to execute? If no, I just like put it, just like you know, if the stage, right, the new from ready, run, terminate, and then we just like wait, and then put it back, and then but we just ignore the interrupt. But right now it's like 5 stage, right? Yeah, so it's really. So that's how it works. And then this one simulate if when we have a queue. So we add a queue. So if we cannot execute, just put it in the queue and then wait and go back again. And for this one, you can refer later, so we can come back. So we don't have a time to cover all this. Here's the example code, but when you are working on the assignment, then you are working on the C++ file. Okay, so you can refer all this, like how can we like doing about the deadlock, and then go to the next one. Okay. So because I already upload all these the Node.js, the JS file to the D2L, so you can download and execute, and then you can check the sequence. You can add the like the log message right here, so you can check the content, the sequence. And also basically for the assignment will be C++ version of this one. So suppose if you have difficulty, then we can like just like this today. I think it would be better like if you have question, then we can spend some time and then go through the question, the code. Okay. Well, I know sometimes because the questions here, they are something is really hard because you are thinking it's like memory something, but just thinking, just to make it simple, try to write a program to simulate it and then do it. I know if you need to read my code or like read my like some sample code, it's really hard to follow the logic. I know it's like it's common, Like when I give you a sample code, but you have to follow the logic, it's really hard. So it's okay. I can share some like solution example, then you can help you to have a better clear idea how to create. Okay.
For me, it was like the longest part was fine.
Mhm.
Like, it's pretty straightforward questions. So really just thinking that we had to get the whole string into the character mode. So,
Mhm.
Yeah, why don't we do it, right? Actually,
which I